Hello, we're back with another video, and today we'll be looking at this practice problem to get you more familiar with what's it called, reaction spontaneity of the signs of delta H, delta S, and delta G. So hopefully with this video you'll be able to see how there's different trends based on the signs of these three values. Okay. So to start off the problem, we see that a key step in the production of sulfuric acid is the oxidation of SO2 gas to SO3 gas. So here we have the reaction, and then what really matters right here is what we're given. So right here for our delta G, we notice that we're given a negative value. For our delta H, we're also given a negative value, and same for our delta S. Now for part A, we are asked, is the reaction spontaneous at 298 Kelvin, right? First, let's predict, how, based off these values, how it's gonna react with spontaneity. So useful tool is to look at this table right here, right? So as you saw from earlier, we have a negative delta H, negative delta S, and negative delta G. So already that, that leaves off this. It won't be that. And then it also won't be this. And then definitely not this. So honestly, the only option that, it could react, or the only one that makes sense, is this one right here, right? And this is without even finding the negative T delta S, but we'll still do that. So we know that it's going to look like this, brackets, so 298 Kelvin, right, times our delta S, which is negative 187.9 joules per Kelvin. So inside the brackets, you're going to get a negative number, and if you multiply that negative times the other negative on the outside, you're ultimately going to receive a positive number. So, everything checks out, right? So we know that this reaction is going to be spontaneous at a lower temperature and non-spontaneous at a higher temperature. So already that gives us a good idea of what to expect for these two answers, right? So I predict that for A, we're going to get spontaneous, and for B, we're going to get